So can anyone tell what is memory? Why we need memory?
Save the data.
Save the data. Okay. Now in PLC, we have two type of memory, bit memory and data memory. Okay. So data memory, when we do the arithmetic operation, we'll see that time. Okay. Now the bit memory. So what is this bit memory? So this bit memories are used to store the input status or output status. Okay. So input or output status. Okay. Now, whenever we use NC or NO switch, what exactly they are giving us? They are giving high or low signal, correct? It will be giving a 1 or 0. They are nothing but bits. Okay, they are binary bits, correct? So now, whenever I use a NO or NC switch, okay. So the output I am getting 1 or 0, correct? So these are bits, correct, guys? Is it correct?
Yes, ma'am.
Correct. So now, whenever I go for push buttons, okay. So whenever I give a, or if I'm using rising edge or falling edge, I need to store that value, okay. Where I'll be storing bit, like a single bit address, address single bit data. So if I go for a data memory, it is a 32 bit or a 16 bit memory. Okay, where it we have will be utilizing complete one data register. Okay, so it is waste of using a data memory. So for that we have a bit memory. These are specially used to store that bits. Okay, let's say I have a push button PB1. Okay, so we all know the operation of push button. Whenever I make it, like whenever I give a press, only at that time it will be on. So it is giving a high signal. What I will do, I will take it to a memory address, let's say M0. Okay. Now whenever whenever I want to use the switch in the program, what will I do? I will be using M0 instead of PB1. Okay. So what I will do, wherever I need a PB1, I'll be using M0. Okay, these are bit memory addresses. Now, how I'll be using this bit memory addresses? I can use it as an input address as well as the output address. Okay, so this bit memory addresses can be used as input address as well as output address. Okay, but we can't see them physically. Okay, they are just registers, a single bit registers we'll be using. Okay, any confusion in this? Understood now?
Yes, ma'am.
So if you want to understand this memories, whatever basic gates we have done, right?
Yes.
So we can store every condition in the memory, then we can take that memory addresses to the output. Okay, if you really want to know how exactly we'll be doing memory addresses, you can use that. Okay, so you have one switch and one lamp. Okay, so now let's say switch on, lamp should be on. Now switch off. So I'll directly write the lamp status. Okay, so lamp should be on. Now again switch on. Lamp should be on. When I make switch off, lamp should be off. Okay. So now you have to do this problem using memories. Okay. Gopi, is your doubt clear?
Yes, clear, ma'am.
Okay. Can you try this problem? So, and memory address here in Omron PLC is 10. It will start from 10.0. Okay.
Okay.
If you feel this is lengthier, we'll do one thing. You do it. Otherwise, you can do it for first two condition. Consider it as first problem. Don't do this too. Okay. I'll remove this. You have only two status. Okay. On and off status. Now try this problem using memories. Okay. I'll solve.
Madam, if can we use two memory bit, right, for one input?
Yes. How much ever memory bits you want to use it. No, it's not a problem. Okay.
Okay.
There is no restriction for memory bits. You can use you have to use only one input and one output, but you can use n number of memories. Okay. Where is the off state? Srinivas, how are you storing the off state? You stored the on state, that's fine. Okay. And again, once again, the lamp will never be on. And you have repeated the lamp address. Output address cannot be repeated. Guys, please remember the rules. Rules are very, very important. There are 4 basic rules. Don't forget them, okay? Inputs can be connected in series or parallel. Output need to be connected only in parallel. Input address can be repeated at the input side. Output address cannot be repeated at the output side, but can be repeated at the input side, okay? And LHS is dedicated to inputs and RHS is dedicated to outputs. Remember this whenever you are writing the program, okay? Always, and one more thing, okay? Whenever you're writing your programs, don't hesitate to utilize the rungs, okay? For every output, how many outputs are there, try to divide them for the different rungs, okay? Once you got the clarity, then try to minimize them. Until then, use as many as switches, lamps are required in your problem, okay? Then try to concise the program. So this is the problem, correct?
Yes.
Everyone are clear with the question, right? This is the problem I have given and this is the output without using memory. Now, let's divide this state of switches, okay? Now, since I'm using single switch, how many states are there? 2 states, right? On and off. Now, what I have to do? So, whenever I have to use memory, I need to store the on state in one memory and off state in one memory, and I have to store them continuously, correct? Correct, guys. Please respond.
Yes, ma'am.
Okay. Now, first I am storing the on state in one memory. Okay. So this is my switch 1. Let me take the memory as M0. Okay. Now, when I switch on, the memory will be storing on state, correct? When I switch off, it will store the off state,
Yes,
correct?
madam.
The
Yes.
both work is done by one single memory. Now, if I use this memory directly here, and this is my lamp, is there any difference between this program and this program? No, right? And the memory will be flickering between on and off state, okay? So I need to store on state continuously and off state continuously. Therefore, I need to use 2 memories. So let me see one more rung. So now this is my switch 1 and I will store it in M0. This is my switch 1 again, but I need to store the off state. Okay, and I'll be storing off state in one more memory. And how I have to store it? I have to store it continuously, correct? So what will I do? I'll do latching here. Okay, it is M0. Okay, and I'll do latching here M1. Okay, now I need to break this latch, correct? I need to break this
Yes,
latch,
madam.
right? So whenever I want to repeat the process, I need to break it, correct? So what I'll do? I'll use here M1. Okay. Now, if I store the off state continuously here, okay, this memory will be always in off state. This also need to be cleared, right? So what will I do? I will use a NO switch. Okay, M0. Okay, this is to break the latch and this is for the repetition purpose. This M0 is used for the repetition of the program. So now what I'll do, I'll just use M0 here and lamp. Okay, got it? So please try it in your CX programmer once. Okay. So now if you have single switch, if you have multiple states like on off, on off, on off, on off, okay, if you want to create patterns, okay, then you can go for this one. Memories. You can store the condition in memory and you can generate patterns in your output. Got it? Any confusion? Sushant, Gopi, Mahantesh, Satya, Radhakrishna.
Once again, where to input impedance again and again.
I didn't get you. Post it in the chat box, please. The voice is breaking.
Repeat once.
Repeat once again. Okay.
Yeah.
Now, see, whenever, see here, I have a one switch and one lamp, correct? Now, whenever I have one switch, a switch has two states. One is on state and one is off state. Okay. Whenever I need to, whenever I have a specific task that I need only on state, or I need only off state. So how I'm getting that state, correct? So I need to get only the on state or only the off state. How exactly I am getting that? So that one we can achieve using the memory. Okay. Whenever I connect the switch in NO contact and I am connecting that NO switch to a memory, then I'll be storing a on status in memory. Okay, I'm now here. See, in the third program, you can see here, I'm using switch 1, okay, in NO contact. That means I'm taking a high condition and I'm storing it in a memory M0. Now this M0 will have only one, okay, that is the on state of switch 1. Okay, now I want to store the off state, correct? So I need to store the off state as well. For that, I cannot use again M0. So to store the off state of the switch, I'll again use the one more memory, that is M1. Now this one is storing only on state and this one is storing only off state. Okay. Now using this on or off state, I can operate the lamp. Since here I want to perform only on and off, I'll go only with the memory M0 at my output. Okay, I'm taking only M0. When I switch on, memory will store a high condition. This high condition will appear here. This will allow the current and lamp will be on. When I make switch off, okay, this M1 will get high and it will break the connection. So by breaking the connection, M0 will get off. Once M0 gets off, lamp will also get off. And this one, since this is in the off state, this will break this latch condition, okay? Thereby making lamp off. Understood? Any confusion? Actually, I
Okay,
should
ma'am,
not
got
be
it.
explaining this. You guys should recognize that, okay? But still, I have explained this one. Understood? This is used for unlatching purpose. Whenever you have used a NC contact, you have to use a NO contact to unlatch. Whenever you're using a NO contact, you will be using NC contact to unlatch it. Okay? Understood?
Yeah, ma'am, actually, here we are using M0 addresses 3 times. Why, ma'am?
Yes, memory addresses can be repeated as many times as possible, even at the input side, even at the output side. Okay, there is no restriction for memory address usage. There's a restriction only for input address usage. Okay. So see, there are input address are dedicated to inputs only, output address are dedicated to output only. But since output is a storing element, that address you can take because the address will be storing 1 or 0. That address you can assign to any switches, but you cannot assign a switch state to a lamp because switch is operated physically. It is a independent variable. Okay, this is independent and this is dependent. Okay, understood? Sushant, any confusion?
Ma'am,
This is a highly confusing topic. That's why I didn't give any problem in this one. Since you guys requested to understand memory, I have given this problem now. There are nearly 7 combinations. I'll give off all those 7 combinations. Try it out. That's your homework for today. Okay?
ma'am, actually, here we are using M0 for motor and M1 for motor 1. So how did we repeat M0?
I'll tell you one thing. Naming is your wish. You can call it as motor, you can call it as a memory, okay? But whenever you're using a specific PLC, there are dedicated memory addresses for each and every PLC. Now, if I take this one, Omron PLC, it is 10.00. If I go for Schneider Electric, it is percentage M0.0, okay? Similarly for Siemens as well, okay? It is also M0.0 only. Okay.
Okay.
And if you go for Allen Bradley, it is B0.0:0. Here M0, M1 means not motor, okay? You're giving a nomenclature to a particular output. It's your wish, okay? Here I'm using M0, M1 as a memory address. In general explanation. If I want to go with a specific address, I can write it as 0.00 and 10.00, okay?
Okay, ma'am.
Any other doubts? Is it clear? Did you guys got the output? Anyone please confirm?
Why we used in second rank? Why we used M0 as a NO?
I'm not as a NO. Don't use it, okay? It's a homework to you people. Don't use M0 here, okay? And try to
Yeah,
repeat the
that's my
process.
doubt also, ma'am.
Okay, I'll do one thing. I will erase this one, okay? See, and I'll connect like this because since I am unlatching it here, the whole process will get off, okay? This is M1, sorry. So this is M0, okay?
Ma'am,
Once
repetition
this
of input address is confusing very much, ma'am.
repetition of input address is confusing.
Yeah, output is M0, M1, and why NO is also named as M1, M0. That is confusing.
That is confusing. You have confusion in basic things only. Okay, listen to me. First, I will clear Mallikarjun's doubt, then I'll come to you. Now, see here, Mallikarjun, don't use this M0. Okay, try to execute only this much process and tell me what output you're getting. Okay, and I want you to make it repeated. Okay, and give me explanation for that. You're
Okay.
using the system right now?
Now, no, ma'am.
Okay. Anyone
Okay.
using Radhakrishna? You're trying it in the system, right?
Ma'am, in the last rung, you used M1, right?
No,
M1.
M0. Sorry, this is M0. I'll write it down here, okay? Because I am owning the lamp, no? I will be using M0. Okay? Radhakrishna, are you there?
Yes, ma'am.
Please try it out this one, no?
Okay, ma'am.
Okay. Okay, now Mahantesh, listen here. Do you know the rules of the PLCs?
Yes, madam.
Okay, tell me what is the first rule of the PLC?
Output.
See, if you want to be, I'll tell you one thing. If you want to be a PLC programmer, even if someone wakes you up in your deep sleep, you should be able to tell your PLC rules. Otherwise, it will be very difficult. Okay? It's like a basic mathematical formulas.
Okay, madam.
Okay? Now, Sushant, tell me the rules.
Ma'am, input address can be repeated and can be connected in series, but output
Don't
cannot be.
tell me how I said you. I had that day, I have shared you PPTs, right? Tell me in a proper format. First one. What is the first rule? Where are you going to connect your switches and lamps, inputs and outputs?
Yeah. Inputs are connected in left side and output are right side, ma'am.
Inputs are connected with LHS and
Output are connected in right side.
so outputs are connected in RHS. Okay.
Yeah.
Now inputs can be connected in
Inputs address can be repeated.
inputs. I'll tell you. Inputs can be connected in series as well as parallel. Okay.
But
Outputs can
output
be connected only in parallel.
Series. Sorry,
parallel, not in series.
Yeah.
Okay. Next.
Okay.
What do you have? Input address can be repeated at input side only. Okay. Output address cannot be repeated. Okay. But output address can be repeated at the input side.
Input side.
Okay. Output address can be repeated at input side, not output side. Okay, you can give it to the input addresses. Understood?
Okay, ma'am.
Any confusion? Now we'll come to the nomenclature part. Okay. Now you're telling that why I am using M0, M1. According to me, M stands for memory. Okay. And M0, M1 are, this one is representing the number of the particular memory. Okay. Understood? So now this M can be motor as well, or it can be valve as well, or it can be stirrer as well. Okay, it's finally up to you. Here, since I'm using memories, I'll be treating this M as a memory address. Okay, Sushant,
Okay, ma'am.
any confusion?
No, ma'am. Clear.
Clear?
ಹಲೋ ಮೇಡಮ್ ಒಂದು ಡೌಟ್
ಏನ್ ಡೌಟ್?
ಮೇಡಮ್ ಅದೇ ಲಾಸ್ಟ್ ರಂಗಲ್ಲಿ ನಾವು M1 ನ NC ಆಗಿ ಯೂಸ್ ಮಾಡಬೇಕಿತ್ತು ತಾನೆ?
ಲಾಸ್ಟ್ ರಂಗಲ್ಲ,
ಹ್ಮ್
ನಾನು ಇಲ್ಲಿ ಮೇಲ್ ಹಾಕಿದ್ದೀನಲ್ಲ ಆಲ್ರೆಡಿ, ಮತ್ತೇನಕ್ಕೆ ಲಾಸ್ಟ್ ರಂಗಲ್ ಯೂಸ್ ಮಾಡ್ಲಿ?
ಆಫ್ ಆದ್ರೆ ನಾವು ಇದು ಕಂಟ್ರೋಲ್ ಮಾಡೋದು.
ತಡೀರಿ ಒಂದ್ ನಿಮಿಷ. ರಾಧಾಕೃಷ್ಣ, ಫಿನಿಶ್ ದ, ಡಿಡ್ ಯು ಡೂ ಇಟ್?
ಓಕೆ ಮೇಡಮ್.
ಒಂದ್ ನಿಮಿಷ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ತಡೀರಿ.
M not ಆಫ್ ಆಗುತ್ತೆ.
ರಾಧಾಕೃಷ್ಣ,
Ma'am, doing, ma'am, just doing. Here, no power, ma'am.
at least your system has a light, right? Screen has a light, right? Okay, fine. Sushant, do you have any other doubts repeating the address switches in there, in that?
No, ma'am. Clear.
Clear? Okay. Now I'll only do that. Someone had doubt in the set and reset as well, right? So now you can see here, this memory 10.00 is storing the on state continuously. Okay. Now, even if I switch it off, it will have the on state only. If I switch it on,
Yes.
it is storing the off state only because of latching. Okay. Now, this memory has only on state and this memory has only off state. Okay. Understood?
Yes.
Any confusion?
No.
No.
Now see here, when I now switch is on, right? My output should get on. Is the output is on?
No.
Why it is not on?
Because it is.
Because
Memory
of this
dump.
memory 2, right? So I'll remove that. Okay. So you can see here, this is storing the off state. I will make it on. Now when I switch it on, lamp is getting on. Now when I switch it off, is lamp getting off?
Oh,
No,
madam.
right?
Latch.
So I need to break the latch. So I will use the NC contact here instead of using at the output side. Okay. Now let me check what happens. Now when I make it on, it is not getting on, right? Even if the switch on, memory is not storing the on state, it is in still off state. Why?
Memory
Because
to
of
off on state.
memory 2, right? Now what I have to do, whenever I switch it on, it should store on state, right?
Memory to off state. ma'am.
So for that reason, I'll be taking here
Another.
a NO switch. See, when I switch it on, it is in the on state, output is also getting on. Now when I make it off, the lamp is getting off. Okay. This is storing the off state. Okay. But it is happening in nanoseconds. Understood? If you want to repeat the process only one time, then don't use this one. Okay. You can observe the process clearly. If you want to repeat it multiple times, then you have to use this one. Okay. Understood?
Yes, ma'am.
Any confusions?
No, madam. Understand.
Sushant, do you
Yeah,
have
ma'am, all right.
confusion in input address and output address repeating?
No, ma'am, clear.
Clear? Anybody else has any other doubts in the memories? I have a few set of problems in memory. I'll post it in the WhatsApp group. Try to solve them, okay?
Okay, madam.
Keep this work to Sunday. Don't do it for tomorrow, okay?
Yeah, okay.
Tomorrow we'll start with the timers.
Okay.
Okay, so we'll go for set and reset. Mahantesh, can you please tell me what's your doubt?
Madam, actually yesterday problem given, madam. That only confusion is there, madam.
That is only confusion.
Yes, madam.
Okay. So can anyone state yesterday's problem? It was what? Wait a minute. Reset. Okay, write a logic to latch the motor when I0 goes from off to on and unlatch the motor with I0.1 goes from on to off. Okay, here I0 and I1 are push buttons. Okay, not the normal switches. Okay, so now take the switch. Mahantesh, you know to select rising edge and falling edge, right?
Yes, madam.
Details. Go for up because they're telling write a logic to latch the motor when I0 goes from on to off. That means from low to high. So therefore I have to take a up. Okay. Then select the function block. Then give set 100.00. Okay. This is your lamp. Now they're telling that I have to unlatch it. It is nothing but reset. Now I have to use it from on to off state. That means high to low state. So what I will do, I will have to use one more switch, but in the falling edge. Okay. Then take reset. That's all is the problem. Understood? Now see here. Imagine this is a push button. Okay. When I give a press. Okay. For a minute press, it will get on. Okay. Now I am pressing this one. Okay. That means here I have to make it on as well as immediately off. Okay. That time it will get reset. Understood? Any
Yes,
doubts?
madam. Yes, madam.
Any confusion?
No, madam.
Clear?
Yes, madam.
Okay, so now you guys don't have any doubts in the basic programming, right? Any others facing any issue taking the rungs, parallel series connection, input output address? Everything is clear, no?